are here at the North Fork of the Guadalupe River in a little town called Hunt in central Texas. The date is November 15th, 2020, and we're going to diagnose this artificial riverbed built in ancient times as part of a continental terraforming project by an advanced race or races in the distant past. Let's begin. The first thing we see along this flooded out creek bank is the inclination of the harder layers. So we have the hard concrete layers, right? Then the softer layer, very thin, soft layer, right? And then an even softer, much deeper layer that's been virtually completely eroded out, crumbling out in little pieces. To level out that angle, we'd have to turn the camera just about that far. It's about a, let's say, 10-degree angle. So these blocks are steeply inclined into the face of the hill, right? Because we have this hill on the right, then we have a hill on the left, and the river bed as the base of the two hills, right? This hill has as its structural components inclined layers, just like we find in South Africa, just like we find in Bosnia, and they're inclined into the face of the structure for structural strength. Now, imagine if these blocks, instead of being inclined into the face of the hill, like this, were inclined like this. That wouldn't be very strong, would it? Because they'd just slip off, boom. But they're not. They're inclined into the face of the hill. So when we look at the hill from the riverbed, we see the bottoms of these. We can look underneath because they've been eroded out. So over thousands, tens of thousands, millions, tens of millions, or hundreds of millions of years, we don't know the time scale because the university geology is ignorant and clownish. We have to come up with a new time scale for all of this because this is not natural, obviously. So over long periods of time, this material has been eroded, and yet the structural layers stay strong. You can feel how strong this material is. Even the material that seems like we should be able to just break it out, you know, these little knobby pieces, they're stuck very, very strongly in. Let's see if we can break this guy off. See, I can't break this off. That's stuck in. Now, that doesn't mean that water won't take it out eventually. Water and temperature differentials. And notice again the 6 or 7 inch layer below it, which has been sealed to it in the ancient past. The ancients baked not just those layers of material, they mixed the recipes, they mixed the magic recipes, baked them, but also baked them so that they would stay strong together. And you can see how strong that is when there's a flood coming past here, and this doesn't even break off. So you can see the seam between those two layers, super strong. Now I want to look at the construction of the top layer, which is built in sections, very, very, very large sections. And we're going to look at some that have been brought down in a minute. Actually, we can look at one right now. There's one right now. That section is several meters square, all right? And most of the sections I've seen are much bigger than that. So these are very, very, very large sections. We would never work in sections this large. We'd make sections a few feet, a meter, maximum 2 meters at most, if we were going to make a creek bank. And we'd make sure we had a channel between them to make sure that expansion of the concrete would have some place to go so that the concrete wouldn't break apart, just like we do with sidewalks. So what the ancients did was make much larger sections because their concrete was much harder and could withstand hot and cold expansion and contraction much better than our concrete. I mean, this is much stronger than our concrete. Now, how do I know that? Because this is reminiscent of the concrete on the Bosnian Pyramid of the Sun. And that is the hardest documented concrete ever analyzed from the ancient past. Far harder than Roman concrete, and harder than almost all of our modern concretes. So 133.8 megapascals is the hardness of the concrete in the Bosnian Pyramid of the Sun. That's the upper hardness rating. And I would guess, but of course we'd have to go to the lab, I would guess that this concrete has a similar hardness rating. Over the millennia, and we could say millennia or millions of years, we don't know, this has stayed strong. And you can see the form of it. You can see that although it's an imperfect side, right, this side right here is imperfect, but you can see the building of it. This has stayed strong over millennia or over millions of years, even when other layers, which are softer, are coming out. Now eventually, the sections do break out, but the sections stay strong. The sections are integral.